Researchers have found the brightest burst of light ever recorded.
The depth of space in scope and color like we've never seen before.
The James Webb Space Telescope, JWST, has recently uncovered a discovery that has set the scientific community ablaze with curiosity and excitement. In its exploration of the cosmos, JWST has detected 5 galaxies so distant, so distinct, and so inexplicable that they are believed to exist beyond the boundaries of our known universe. These galaxies defy our current understanding of astrophysics, challenging our notions of what lies beyond the observable universe and forcing astronomers to rethink the limits of cosmic exploration. The implications of these discoveries are profound, hinting at the possibility that our universe may not be the only one, that we may in fact be on the brink of uncovering evidence of a multiverse. Before we start, hit the like and subscribe buttons for more exclusive news. When JWST first detected these 5 mysterious galaxies, scientists were initially hesitant to believe the data. Positioned at the outer edges of what our telescopes can observe, these galaxies appeared to exist at distances and in configurations that did not match any known cosmic model. The initial readings from JWST suggested that these galaxies were not only far beyond our observable universe, but they also possessed unique structures, properties, and energy signatures that contradicted our current understanding of galactic formation. Unlike the galaxies within our universe, which tend to follow established patterns based on gravity, mass, and the presence of dark matter, these newly discovered galaxies seem to function according to entirely different rules. Their discovery hinted at a form of cosmic evolution that operates under unknown principles, revealing a potentially deeper layer of reality that has eluded us until now. The mere existence of these galaxies is enough to shake the foundations of physics. In standard cosmology, the observable universe is believed to be about 13.8 billion years old, with light having only been able to travel a finite distance since the Big Bang. This constraint defines the observable limits of the universe, creating what scientists refer to as the cosmic horizon. Objects beyond this horizon are assumed to exist, but they cannot influence or be observed by us due to the finite speed of light. However, the galaxies detected by JWST appear to reside beyond this horizon, suggesting that they may belong to an entirely separate reality, or perhaps even another universe. If these galaxies are indeed from a realm beyond our own, it would imply that the cosmic horizon is not the ultimate boundary of existence. Instead, it might just be a perceptual limit imposed by our position within a vastly larger and more intricate cosmic structure. The discovery of these galaxies challenges one of the most fundamental principles of physics, that the laws of nature are universal. For centuries, scientists have worked under the assumption that the same forces that govern our solar system, galaxy, and universe apply universally. Yet, JWST's findings suggest that these distant galaxies may operate under an entirely different set of physical laws. Some of these galaxies exhibit energy levels that are difficult to explain under our current understanding of thermodynamics and quantum mechanics. They appear to be powered by unknown sources, possibly new forms of energy that do not exist or are not yet understood within our universe. This revelation is not just surprising, it's revolutionary. The idea that other universes with different physical laws might exist has been a topic of theoretical speculation for decades. But now we are faced with what may be concrete evidence of such a reality. The implications of these findings extend beyond the scope of astrophysics and into the realms of philosophy, metaphysics, and even spirituality. For centuries, humanity has grappled with questions about the nature of existence, the origins of the universe, and the possibility of other worlds. The detection of these galaxies adds a new dimension to these age-old questions, suggesting that the reality we experience is only a small part of a much larger and more complex system. If there are other universes with different physical laws, it could imply that our universe is just one iteration in an infinite tapestry of realities. Such a possibility would mean that our understanding of existence is only partial, and that there may be other beings, possibly even other forms of life, living in these alternative universes. Another striking feature of these galaxies is their apparent age. Current cosmological models suggest that galaxies take billions of years to form, growing gradually as stars coalesce and galaxies merge. However, the galaxies detected by JWST appear to have formed in a fraction of that time, possessing fully mature structures that are inexplicably old, even by cosmic standards. This discovery could indicate that these galaxies were formed in an environment radically different from our own, where time and space might function differently. If time flows differently in these regions, it might mean that our understanding of time as a linear, constant progression is only a localized phenomenon, bound to our own universe's specific physical parameters. Such a discovery could revolutionize the way we understand time itself, suggesting that it might be malleable or even multidimensional in other realities. The nature of light coming from these galaxies further adds to the mystery. Typically, light from distant galaxies appears redshifted due to the expansion of the universe, a phenomenon known as the Doppler effect. However, the light from these galaxies has properties that do not fit neatly into the redshift paradigm. Instead, their light exhibits peculiar spectral signatures that imply unknown forms of matter or exotic particles that do not interact with light in the same way as the elements found in our universe. These spectral anomalies could point to the existence of new types of matter or energy that have yet to be observed in our reality, possibly including states of matter that are theorized but not yet proven, such as dark energy or hypothetical particles beyond the standard model. Such exotic matter, if verified, would provide insights into the building blocks of other universes, giving us a glimpse into realms that operate under fundamentally different rules. This discovery also reignites the debate over the multiverse theory. While the concept of a multiverse, an ensemble of multiple universes existing simultaneously, has long been considered speculative, these findings from JWST might provide the first observational evidence to support it. If these galaxies are truly from beyond our universe, then they could be part of a vast multiverse, where countless other universes coexist with our own. Each of these universes might have its own unique physical laws, cosmic structures, and forms of life, representing variations on reality that we can only begin to imagine. The idea of a multiverse has been championed by some of the most respected physicists, such as Stephen Hawking and Max Tegmark. But until now, it has been impossible to obtain observational evidence to support it. The discovery of these galaxies could be the first step toward proving the multiverse theory, a breakthrough that would fundamentally alter our conception of reality. The potential existence of a multiverse also raises profound questions about the origin of our own universe. If there are indeed other universes beyond our own, then it is possible that our universe was not a unique, isolated event. Instead, it could have been one of many universes that formed in a cosmic cycle or as part of a larger structure of interconnected realities. This idea could have significant implications for our understanding of the Big Bang. Traditionally, the Big Bang is considered the beginning of all things, the moment when time and space were created. However, if other universes exist, then the Big Bang might simply be one of many such events, part of an ongoing process of universe formation within a multiverse. This would suggest that the creation of universes could be a natural phenomenon, possibly occurring in cycles or through mechanisms we do not yet understand. The discovery also raises new questions about the potential for communication or even travel between universes. While this idea remains firmly in the realm of science fiction, the detection of galaxies beyond our observable universe invites speculation about whether it might someday be possible to bridge the gap between realities. If these other universes exist in a tangible way, then there could be unknown forms of energy or technology that might allow us to interact with them. Such a possibility, though far-fetched, opens up tantalizing questions about what it would mean to connect with other universes, possibly even to visit them. Would these other universes be hospitable to us, or would they be so alien that human life could not survive? Could they hold advanced civilizations that have already discovered ways to traverse the boundaries between realities? The scientific tools we currently possess are only beginning to scratch the surface of what lies beyond our universe. JWST's capabilities represent the pinnacle of human achievement in space exploration. Yet the discovery of these galaxies shows us just how limited we still are. The cosmos, as vast and ancient as it is, contains mysteries that we are only beginning to uncover. JWST has given us a glimpse into a reality that we never imagined, one that challenges every assumption we hold about the nature of existence. It serves as a reminder that the universe, or rather the multiverse, is far more complex and beautiful than we can currently understand. The journey to unravel these mysteries is just beginning, and as we continue to explore, we may find that our greatest discoveries are still ahead of us. These galaxies, with their strange properties and unexplainable characteristics, might ultimately serve as a cosmic invitation, urging humanity to look beyond the limits of our understanding. They represent a call to adventure, to seek out new knowledge and expand the boundaries of science. The discovery of galaxies beyond our universe is a momentous step forward, one that could usher in a new era of scientific exploration and philosophical inquiry. It is a reminder of our small place in a grand, interconnected reality, one that stretches beyond the stars and invites us to wonder about what lies beyond. One of the most intriguing aspects of this finding is how it redefines our sense of place in the cosmos. Throughout history, humanity has tried to center itself within the universe. Ancient astronomers once placed Earth at the center, and even as we expanded our understanding to recognize our solar system's smallness within the Milky Way, we still perceived ourselves as central within the observable universe. The notion of galaxies existing in other universes upends this concept, positioning our universe not as the sum of all existence, but as a single island within a vast ocean of realities. If these other galaxies exist beyond our universe, they may belong to a separate yet equally vast observable universe with its own inhabitants, mysteries, and evolutionary pathways. This radical expansion of our cosmic perspective carries with it a more profound philosophical weight. For millennia, we have pondered the nature of reality, considering whether what we see, feel, and understand represents the true nature of existence. The potential discovery of parallel universes or unknown realms brings a new dimension to these contemplations, suggesting that our reality may simply be one layer of a multifaceted existence. Ancient philosophical traditions, from the multiverse speculations of Greek atomists to the Buddhist concept of infinite worlds, have touched on this idea in a more spiritual sense. Now, with JWST's discovery, we have the beginnings of empirical support that could ground these ancient intuitions in scientific reality. Scientists and theorists are grappling with how these galaxies could exist in such distant, seemingly inaccessible realms. Some propose that they might represent regions of space-time that were once connected to ours in a distant pre-Big Bang era. According to one hypothesis, our universe may have budded off from a larger cosmic entity, like a bubble in a sea of other universes, each with its own laws of physics. This would mean that these other galaxies might have existed before our universe separated from its parent reality, persisting in their own evolutionary paths ever since. Such a notion redefines the Big Bang not as the beginning of all things, but as a phase transition, a moment when our universe differentiated itself from a more extensive pre-existing state. In light of these revelations, physicists are re-evaluating fundamental theories in search of frameworks that might account for such distant, inaccessible realities. Theories like string theory and M theory, which propose additional dimensions beyond the familiar 3 spatial and 1 temporal, might offer explanations. If these extra dimensions do exist, they could represent pathways or channels connecting different universes or realms. These dimensions, too small to observe directly, might hold the key to understanding how seemingly disconnected galaxies could still affect or relate to our own universe. M theory, which suggests an 11-dimensional universe, posits that what we perceive as separate universes might in fact be connected through higher dimensional spaces that we lack the means to perceive or measure. One potential model, known as the brain multiverse theory, theorizes that universes exist as separate brains floating in a higher dimensional space, sometimes coming into contact and influencing each other. If these galaxies detected by JWST exist on another brain, then their proximity to ours might be purely an illusion caused by their closeness in higher dimensional space, rather than spatial distance as we understand it. These contacts between brains could potentially explain the strange energy signatures and unusual light behavior observed in these galaxies. Our instruments, designed for 3-dimensional space, might be detecting the residue of energy transfers or gravitational effects caused by the occasional interaction of our universe with another, leaving imprints visible only to an instrument as sensitive as JWST. Moreover, the very appearance of these galaxies, with their structures and energy forms so different from any known models, raises questions about the adaptability of life and matter in these alternative realities. If galaxies beyond our universe are real, then they could support entirely unfamiliar types of matter, star systems, and potentially even life forms. Life, as we understand it, is a byproduct of the laws of physics that govern our universe. Laws that dictate how atoms bond, how cells function, and how energy flows. In an alternate universe with different laws, life could exist in forms beyond our comprehension, perhaps relying on chemical or physical processes that would be impossible under the conditions present in our universe. This discovery pushes scientists to explore the limits of imagination and scientific conjecture. How might conscious beings, if they exist in these other universes, perceive their reality? Would they see their own universe as the entire scope of existence just as we have? Would they have detected our universe or others? Such questions push the boundaries of empirical science and bring us face to face with a philosophical realm that defies testing and measurement. Yet, with every advancement in technology, from the JWST to future space telescopes that could succeed it, we move closer to turning such speculation into a form of observable science. This potential expansion of our empirical reach hints that one day we might have tools capable of directly interacting with or observing these other realms. What makes this discovery particularly significant is how it compels us to rethink the nature of energy and matter. If these galaxies are subject to different physical laws, the properties of matter there may be vastly different from those in our own universe. This could mean that matter, energy, and possibly even consciousness itself are more versatile and adaptable than we ever imagined. For instance, what we define as matter might only be a local adaptation of a more fundamental, malleable form of reality that changes according to the governing rules of each universe. If energy and matter can take on different forms under alternate physical laws, it suggests that our understanding of physics is a localized perspective, constrained by the characteristics of our universe. One tantalizing possibility is that these galaxies might possess different forms of gravity or even alternative forces altogether. Scientists have long speculated about the existence of other fundamental forces beyond the four recognized in our universe: gravity, electromagnetism, and the strong and weak nuclear forces. If other universes operate under different physical rules, they may be dominated by forces we cannot detect or understand. This opens the door to imagining universes where reality itself feels different, where perhaps stars don't shine due to nuclear fusion, but by other unknown processes, and where the bonds that hold matter together operate on entirely distinct principles. JWST's findings also raise questions about the role of consciousness in perceiving reality. If we are part of one universe among countless others, it's worth considering whether consciousness could also take on different forms in other realities. In a universe with altered physical laws, might there be conscious beings who perceive time, space, and existence in ways unimaginable to us? Could consciousness itself be a phenomenon that adapts to the conditions of its environment, much like matter and energy? This discovery could lead to a new era in the study of consciousness, one that considers not just the brain or biology, but the fundamental nature of existence across various forms of reality. Perhaps most astonishingly, the discovery of galaxies beyond our universe forces us to grapple with the concept of infinity. The existence of multiple universes suggests that reality itself could be boundless, an ever-expanding collection of realms, each with its unique configuration. Infinity in this context is not merely an abstract mathematical concept, but a tangible reality filled with endless variations of existence, each as real and concrete as our own. This challenges the way we think about purpose, meaning, and the human place within the cosmos. If we are part of an infinite reality, how do we define the significance of our existence? Does meaning change if our universe is one of countless others, each with its galaxies, stars, and possibly its forms of life? For humanity, the detection of these other galaxies is both exhilarating and humbling. It shows us that even the most advanced scientific tools we possess are only scratching the surface of a vastly complex reality. JWST's glimpse into these distant galaxies suggests that our journey of discovery has only just begun and that we may be standing on the precipice of a new era in cosmology. It's a profound reminder that every answer we find about the universe leads to new questions, each more profound and far-reaching than the last. The more we learn, the more we realize how much remains to be understood. Moving forward, this discovery will likely drive a wave of innovation in scientific instrumentation, as scientists strive to develop tools capable of probing these alternate realms more directly. We may see a new generation of space telescopes, each more powerful than the last, designed to peer even further into the depths of existence. This quest could ultimately lead to breakthroughs in technology and physics that we can scarcely imagine today. Concepts that seem purely theoretical, like wormholes or interuniversal travel, might one day move from the realm of science fiction into scientific plausibility, bringing with them new possibilities for exploration and understanding. One of the most mind-bending aspects of this discovery is the potential implication for the concept of causality. In our universe, causality, the idea that cause precedes effect, is a foundational principle. However, if other universes exist with different physical laws, then the nature of causality itself may vary across these realms. These distant galaxies may follow causal relationships that are foreign to us, where time may not progress linearly, or cause and effect might not operate in the way we understand. Imagine a universe where events are not bound by linear time, where the past, present, and future could intermingle in ways inconceivable to our experience. The existence of such galaxies could challenge our deepest assumptions about temporality, forcing us to ask whether causality, as we know it, is merely a byproduct of our universe's particular configuration. The structure of space-time is another area thrown into question by these findings. In Einstein's general theory of relativity, space-time is a continuous fabric that can be stretched and bent by the presence of mass and energy. But if these galaxies belong to another universe, they might exist within an entirely different space-time configuration. Such a universe might not even be bound by the concept of space-time as we understand it, instead existing in a realm where dimensions and the concept of distance operate in ways that our current models cannot describe. These differences in spatial structure could mean that, while these galaxies appear distant to us, they might actually be closer within their own dimensional framework. This could redefine what we understand as distance or proximity, introducing a new paradigm in which universes coexist in ways that are more intricately interwoven than we ever imagined. Another critical aspect to consider is the possible interaction between these galaxies and our universe. While they may reside in a separate realm, it is conceivable that there are points of overlap or intersection where the boundaries between universes become porous. In such regions, energy, particles, or even information might be able to seep through, creating what some theorists refer to as bridges or tunnels between universes. These intersections might explain why we can detect these galaxies in the first place. Perhaps we are observing their light as it slips through a kind of cosmic portal. The notion of multiversal interaction challenges our understanding of isolation in the cosmos, proposing that our universe might not be as insular as we once believed. This concept of interuniversal bridges aligns with emerging ideas in quantum mechanics, particularly around the concept of quantum entanglement. Entanglement suggests that particles can remain interconnected across vast distances, with the state of one particle instantly influencing the state of another, even if they are separated by billions of light years. Some physicists speculate that this phenomenon could be a hint of a deeper underlying connectedness across universes. If particles in our universe can be entangled with those in other universes, then it may be possible for information to transfer across realms in ways that circumvent the constraints of space-time. This line of thought opens up the tantalizing possibility that we might one day communicate with or even observe other universes through quantum entanglement, connecting disparate realities in ways previously thought impossible. The detection of these galaxies could also provide insights into the nature of dark matter and dark energy, two of the most mysterious components of our universe. Dark matter, which makes up about 27% of the universe, and dark energy, which constitutes around 68%, are forces we do not fully understand, but know must exist to explain gravitational effects and the accelerating expansion of the universe. If other universes operate under different physical laws, it's possible that dark matter and dark energy might represent a kind of residue or echo from interactions with these other realities. The gravitational effects attributed to dark matter, for instance, might be the result of unseen mass from another universe exerting influence on our own. Similarly, dark energy might be a byproduct of the interaction between universes, an outward push generated by the proximity of other realms beyond our perception. This line of reasoning could offer explanations for some of the anomalies observed in astrophysics, such as the unexplained rotational speeds of galaxies and the large-scale structure of the cosmos. If galaxies beyond our universe are exerting forces or influencing our own, then what we consider dark forces may simply be the manifestations of these interactions. This would imply that our universe is far from isolated, instead existing within a complex, interconnected web of universes whose gravitational fields and energies subtly shape one another. Such a revelation would redefine our understanding of the cosmos, positioning our universe as part of a grand, interlocking system rather than an independent entity. The potential existence of other universes also brings forth the possibility of different evolutionary pathways for matter and energy. In our universe, elements form through nucleosynthesis within stars, creating the periodic table as we know it. However, in another universe with different physical constants, entirely new elements, compounds, and states of matter might exist. This could mean that materials with properties beyond anything we can imagine, substances that defy our understanding of solidity, conductivity, or reactivity, might be commonplace elsewhere. For instance, a universe with altered atomic structures might yield forms of matter that can conduct energy without resistance, or elements that exist in stable states of matter unknown to our universe, such as hypothetical forms of metamatter that could be crucial to understanding the broader multiverse. The strange properties of these otherworldly galaxies may also point to new forms of energy generation and consumption. In our universe, energy follows specific laws, particularly thermodynamic principles that limit how it can be used or transformed. If energy behaves differently in other universes, then these galaxies may harness forms of energy conversion that challenge our understanding of efficiency and entropy. Imagine a universe where energy loss is minimized to an extreme degree, allowing processes and machines to operate with almost perpetual efficiency. Alternatively, these galaxies might tap into entirely new types of energy that we cannot yet perceive, such as energies derived from higher dimensional interactions or quantum fields unique to their reality. Such discoveries could lead us toward unimaginable advancements in energy technology, potentially providing clues to solving some of the greatest challenges humanity faces. Another striking implication of this discovery is what it suggests about the potential for consciousness in alternative forms. In a universe where matter and energy interact differently, conscious beings